Now in this video, we are going to start another important topic called arrays. As we have discussed in the data types, like arrays are the part of reference type which stores the reference on the stack and their value is stored in heaps. But the question comes in which particular situations we can use these arrays. So basically in programming you may come across a situation where you can store multiple values of same data types. So in that particular situations, rather than defining the multiple variables of same data types, you can define an array, and along with the definition you also have to specify the size of that array. That size will remain static, that means you will not be able to decrease or increase the size after it is defined. So now as you can see, it's a fixed size and sequential. That's again an important part, that when the values will be stored in the heap, the complete memory allocation will be a fixed and sequential collection of memory blocks. Fixed means you will not be able to change, and sequential means every memory block will be right after each other and they must be of same type. Like here you can see, once you have defined the array, it will look something like that. Actually not, but yes, it is a pictorial representation. So it will be a sequential memory allocation like that, and now what you can do, you can access each and individual item in the collection by passing an index. As for example, numbers is the name of my array, so this complete array has a common name, but to identify or to retrieve a specific element, the index will work. Index will always start with a 0 and will go to the length minus 5. For example, if the length of an array is 5, it will start with a 0, 1, 2, 3, 4, that is length minus 5. Fourth is the last index, alright. So you can pass a particular index to retrieve or to assign a value. Alright. So like here you can see how we can define the array. There are three different ways which we have mentioned here. First is int is a data type, square brackets. Whichever data type you will pass, it will become the array of that specific type and it will be type safe now. So ARR1 is the name of my array, and here new keyword will allocate a new space in the heap. And now 5 is the number of blocks which will be occupied of integer type in the heap. Alright, so 0, 1, 2, these are what? These are the index on which I am assigning a value. As you can see, I have assigned size 5, that means the index will go till 4, but I have assigned only 3 values. So what will happen to the remaining ones? They will be initialized, or I should say all the array elements will be initialized by default with a 0. You can definitely override them. Or you can go for this particular way if you have some fixed values which you want to store in an array. Here I have done the inline initialization, in which after specifying the size of an array, I'll have to pass the same number of elements. If you will change the number of elements right here, whether less or more, it will give you a syntax error. Or in the last way, where I have not specified the number of elements right here, I can pass as many as elements I want, but whatever the number of elements I will pass in the first time, that will be the size of this array, and as I said, later in the same program you will not be able to change it. So this is one type of array, that is the linear array. You can create the arrays logically multiple types. Like here, I have classified them into 3 different parts, that is single dimensional array, multi-dimensional and jagged array. So we have already seen single dimensional array in the previous example. Now here you can see the multi-dimensional array. In the multi-dimensional, I have taken 2-dimensional array where you can specify the number of rows and columns by separating them with a comma. So here you can see this represents the multi-dimensional array, in this case 2-dimensional. ARR1 is the name of your array, and while allocating the memory, I have specified 2 rows, 3 columns. So first row 3 elements, second row 3 elements. Similarly, as I did earlier, I have not specified the number of rows and columns here, but when I will pass the values they will be the size of the array. And as here you can see, I have not initialized the elements right here. Everyone will be initialized with a 0 by default, and later I can change the value by passing the index of row and column. So this is how you can define the multi-dimensional array. And the last one here is jagged array. Jagged array is also called array of arrays. For example, if in any situation you have to create multiple arrays in a program and you want to bind all those arrays in one array, so you can go for the jagged array. As here in the syntax you can see, this is integer, integer array and integer array of arrays. So I initially told like I am going to store 3 arrays inside, and after that I will not specify any number of columns because it is not a number of column, there are 3 arrays. Now after that I will have to initialize each array separately, like 0th array, 1th index and 2th index. Alright, so size is 3, 2, 4 respectively along with their elements. So this is how you can define the different types of array in C# programming. Now let's go practically and see how we can retrieve the values along with performing some more operations like searching and sorting. In this example, I have taken very simple program for array. As you can see, I have taken an array of integer type and I am doing the inline initialization. You can also define an array in the various syntax as we have discussed earlier in the session. In order to print the values or access individual values from this array, what you can do, you can simply pass the index which element you want to read. Like the index will start from 0 to the length of the array -1. So its 6 elements are there. So 0 will be the starting index and 5 will be the last index. So when I will execute it, you can see the first element got printed. To read the complete array, you can also write a loop which will start from 0 till less than 6, that is 5. So whenever you will execute it like arri, it will retrieve all the elements of the array. Similarly, here we have one more loop now for reading the collection like objects, which we call the for each loop. We have not discussed this loop in the iterational statements because array is mandatory whenever you use the for each loop. Either it could be an array or any collection like thing. So like int item in the collection name is arr. So this is how you can use this for each loop, where each element of this arr array will come into this variable called item one by one. You don't have to pass the index or the size of an array. It will automatically take the value from here. You can simply print this item to get all the elements of this array. So as you can see, the output is very similar. But you can use for each loop only for the retrieval of an array. You cannot assign the values into the array using for each loop. So while working with the collection, some operations are quite normal, like reading the data from the collection or sorting the data or finding an element from the collection. So as you have already seen, like in this example, I have already read the elements. So let's do some more operations like here. Now you can see I'm doing a sorting in this array. So when I will execute it, you can find the elements are in the sorted order. So let's see how I am doing this. The technique which I am using here for sorting the element is called the bubble sort. There are so many techniques if you will go through the data structure, but here I am using only one of them, where as previous example I have initialized the array. I have taken a temporary variable, and here what I am doing inside this array, I am actually reading all the element till the length -1. So that what will happen, whenever this loop will execute, one element will be compared to its right after element. Like here you can see if j is 0, so if arrj means 0 is greater than arr1. If it is so, and obviously I want to sort it in the ascending order, so when the previous element is greater than the next element, I am just doing a swapping in these 3 lines. This 3 will come here and 7 will go here. Similarly, this loop will go through from 0 to length minus 1. Length of the array is 6, minus 1 is 5, and less than 5 means 4. So since this index is 4 and 4 plus 1 is 5, which you will use right here. So this is why we are running it one step lesser. But in one complete iteration of this loop, your array will not be completely sorted. So just to iterate this particular loop, I have passed one more loop here, which will repeat this inner loop again and again. In the bubble sort, if the number of elements of an array is n, so maximum you require n into n minus 1 iterations should be there. So this is what we have done here, and after that when we are reading the elements, you can see the array is completely sorted. If you want to sort this array in descending order, you can simply pass less than symbol here, and now it is in descending order. You can see in this program I am doing a search operation. Searching could be done as a linear search or binary search. For binary search, first of all you will have to sort your array and then you can perform a binary search. But here I am simply taking a linear search where user will enter any value and I will search that in this array. If that element is found, I will give a message element found, otherwise element not found. So here there is a boolean variable called found, which I initialized with false, and any time when the given number is equal to the any of the number in the array, we will say found is equal to true, because obviously we got that element and then I don't require to run this loop again. So I wrote break to terminate this loop immediately. If found is true, which you can see, it will be true only when this condition is true. So we will print element found, otherwise element not found. So these are some very basic operations that you can do using a linear array or single dimensional array for sorting and searching. Now when I talk about multi-dimensional array, two-dimensional array is a very common example. And here you can see I have separated these with a comma, that means number of rows comma number of columns. And right here I have initialized it with the size 3 rows and 4 columns, and again I have done the inline initialization, like row 1 4 elements, row 2 4 elements, and row 3 4 elements. I'll have to do the nesting where the first loop will take care of the number of rows and second loop will take care of the number of columns. So for each particular row I am printing all the values available in each column, and then I will break the line. Again I++, that means another row, and again all the elements will be red. So the output will somewhat look like this. So this is how you can do some more operations using the multi-dimensional array in C#. As I discussed earlier, we are working with the array, but when you want to take multiple arrays of different sizes, you can take an array of array. That's what we call the jagged array. So let's find a very simple example where I will define the array and then read all the elements from that. So this is what I call the jagged array. Here you can see this is integer, integer array, and integer array of array. So this ARR is now a jagged array in which I told like I am going to store 3 arrays, but I have not mentioned the size. When I will initialize each array out there, I will pass the size of each array, and I can also initialize the element at the same time. In the for each loop, I'll again have to do the nesting, as first of all, from this array of the array, one array will come into this AR, and then from this AR I will read all the elements. Similarly, you can do the nestings in the similar way using the for loop as well. So when I'll execute this program, in the first row there are 3 elements, 3 elements got printed. In the second row only 2 elements, and in the third row there are 4 elements as I designed right here. This is how you can make a use of different types of array whenever it is required in your C# programming.